This is creative problem set number 8, problem number 6. There are 3 underground gopher nests in a field. Call them A, B, and C. There are tunnels between A and B, between B and C, and between A and C. A gopher counts that there are 98 ways to get from A to B, and there are 91 ways to get from A to C. How many ways are there to get from B to C? So I'm going to set up a model of what we're going to use in order to find this number of ways to get from B to C. So if we have A, B, and C, and let's say I have 4 tunnels to get from A to C. 3 tunnels to get from B to C, and 2 tunnels to get from A to B. So if we wanted to know the total number of ways to get from B to C, using what the problem says that a way to get from A to C is you can either take a direct tunnel to get from A to C, so one of these 4 tunnels, or you can take a tunnel from A to B and a tunnel from B to C. So similarly, if we want to find how to get from B to C, we can take direct tunnels from B to C, which is 3, plus if we take this first tunnel from B to A and then this first tunnel from A to C, or we can take this first tunnel from B to A and the second tunnel from A to C. So we're going to have different combinations of tunnels from B to A and A to C. So we're going to multiply those. So we have 2 times 4. So this is what is going to help us figure out the total number of ways to get from B to C. So I'm going to redraw this, and we're going to replace the numbers with variables. So the number of tunnels between A to B, I'm going to call X. From B to C, I'm going to call Y. And from A to C, I'm going to call Z. And what we want to know is the total number of ways from B to C, which is Y, because directly from B to C is Y tunnels, plus the combinations from B to A and A to C, which is X times Z. And what we already know from A to B, we have X plus Z times Y, which equals 98, because they already told us the total number of ways from A to B is 98. And from A to C, we have Z number of tunnels plus a combination of X and Y, which equals 91. Next, what I did was I took these 2 equations and I just subtracted them from each other. I factor out a negative Y. And I factor out an X minus Z. So each of these quantities can multiply up to equal 7 using the integers of 7, which are 1, -1, 7, -7. So if we made this green quantity here 1, and 1 minus y 7, that would multiply up to be 7. Similarly, if we make this -1 and this -7, and if we mismatch them, we have 7 times 1 and -7 times -1. But since we want to know the tunnels from B to C, we're going to set 1 minus y equal to these integers. That should be a -1. So y could equal -6, 8, 0, or 2, but we can have a negative number of tunnels, and we can have 0 number of tunnels. So we can have 8 tunnels directly from B to C, or 2 tunnels. So one possible answer is when the number of direct tunnels is 2. So we're going to use these two equations up here to solve for x and z. So we have x plus 2y equals 98. And I'm going to bring this x so it's underneath this x here. So we have 2x plus z equals 91. Going to multiply the top row by 2. We have 2x plus 4z equals 196. Going to subtract. Z equals 35. Then I'm going to use this, well, either one you can use to find z, x, and since we have z and y, I'm just going to use the first one. So x plus 35 times 2 equals 98. X equals 28. The second way is when y equals 8. And you just similarly do the same steps. By top by 8. Solve for x. So we get x equals 10. Now we're going to use these variables and we're going to solve for a number of ways, number of tunnels from B to C, which already established that it's y plus x times z. So one way is when y is 2. We have x is 28 times 35, which equals 982. Second way is when y equals 8 plus 10 times 11 equals 118. And those are our two possible answers.